All right. So if you had not had a chance to see the announcement for this week, as I said last week, we are wrapping up Unit 1. I'm going to start teaching Unit 2 today. And I know that our assessments are a little delayed, meaning like we have the quiz over 1C through 1E due tomorrow, and then your first exam over all of the unit isn't due until next Tuesday, right? Tuesday the Tuesday the 26th, right? You can always take your assessments early. I don't grade them though until everybody has done them. So like you can take your test or your quiz early, but I won't grade it until after the due date for everyone. But again, I encourage you to do it early. Don't wait until that last day. You never know what's going to happen or what's going to come up, and that can always throw a wrench. People sometimes think that if that's the due date, that's literally the only date that you can do it on, and you can always do it early. So my plan, like I said in there today, I'm just going to do 2A and maybe get into 2B. 2A and 2B and 2C are really big. And so we'll see how much I get done of each of them in those days. But again, today my plan is to go over 2A. Tomorrow, I'm going to go over the quiz and then again touch on the gradebook project. So before you come to class tomorrow, look at the gradebook project, try to get it going. And so my plan tomorrow is to go over the quiz and then answer any questions you have about the gradebook project so that you can have some dedicated time to ask questions about that. And then obviously Thursday, I'll get into 2B. So questions for me before I get started?
I have a quick question, if that's
Yes.
okay. Okay, actually two. The first one is the exam is due on Tuesday. Does that mean we can do it on Tuesday, or do we have to do it on Monday?
No, you can do it Tuesday. You can do it Monday. You could do it Friday of this week. It's up to you. You just have to have it done by Tuesday at, I believe it's 5 p.m. is when the Foundational Math Center closes.
Okay.
Hours.
Perfect.
And so, Tuesdays, it looks like they close at 6 p.m. So I will make sure that our due date reflects that in Pearson. Also, what was I going to say? If you're doing it somewhere else, like you have a proctor, you got to keep that in mind because that due date and due time will also be reflected for you. And so if you're having issues with that, talk to me, okay? But again, our exams are due at the date or at the time, that the Foundational Math Center closes. If you are in the Libby area, you need to make an appointment with the front desk there and talk to Seth, I believe, or Dawn, I think works at the front desk sometimes too. And they will be able to get that scheduled for you. Obviously, if you're in the Flathead Valley area, you need to go to the main campus to take your exams. You do not need to make an appointment, but you have to go during the hours that they are open. And so Monday it's from 10 to 5, Tuesday it's 9 to 6, Wednesday 9 to 6, Thursday 8 to 4, and Friday 8 to 4. And if you want to know what those hours are on our our Eagle Online homepage. If you scroll to the bottom, there's a link to the Foundational Math Center, and if you go to their page, you'll be able to find that stuff. And then lastly, like I said in my post, if you live in none of the areas that I have just talked about and you need to have a proctor set up, then you need to get together with Grace and she can help you coordinate that. So, and I always suggest going through a public library. They are wonderful. They can usually get that done. But it's always good to start trying to set it up now so we have time before your exam is actually due.
Okay, thank you. I have one more question.
Sure.
It kind of has more to do with like me personally and my take on the homework, but so do you go through and look at the answers on the homework that we do through Pearson? Because I kept doing the math over and over and over again for a specific problem, and I kept getting the same answer, and I kept putting it in, and it kept saying I was wrong, but it's because I was putting in like 89.45 and they wanted 89.4, but
Right.
I thought we were supposed to either round up or not round at all, so I was a little bit confused on that.
So I don't look at them unless you email me about them. And Kendra, I feel like you did email me and then it got lost in the shuffle. I know I feel like we talked about this in email. Am I remembering this correctly?
No, that was about the first quiz.
Okay.
It was something about me and like uploading files, but this time I didn't get the answer correct because I just was off a decimal, which is fine, but I'm wondering if you ever like, look at those things.
I don't, not unless you email me that you're having a hard time with the way that it's like with the answer that you're putting in versus what it's asking for. So again, I wait for you to come to me, because with having so many opportunities to get the answer right, I don't take the time to look through your homework. But if you're having an issue with entering it, don't use up all your opportunities, obviously, and email me and I can look at it and see where maybe you're misinterpreting what they're saying or why it's not matching up or what's happening. So if you want to send me a direct message, Kendra, with a problem specifically you want me to look at and like why it didn't like your answer, I can send you an email with some more information about that.
Okay, I figured it out afterwards. It was rounding it down for some reason. But I was just curious on that because I felt like I was doing all the steps right. It was just that one answer that was incorrect, but it's no big deal. Thanks for explaining that to me.
Well, and again, so that's the idea of like, why did it want me to round down when maybe I wouldn't normally round down? And that's a good question for just looking at what is the problem, like what is the situation of the problem. I don't think I'm expressing myself properly. What I'm trying to say is that sometimes the problem is written in a real world setting and it can make sense as to why within the setting it wants you to round down, where you normally wouldn't think of that in terms of your rounding rules. Does that make sense?
Yeah, I understand.
Okay. So that's where, again, like you very well could be doing the math correctly. But because of the setting that the problem is set in, if we're looking at number of people per whatever, you're not going to necessarily give an answer of a decimal portion of a person, or that sort of thing, can sometimes lead us to have weird rounding issues because it goes against what we would think we would do in that rounding situation. More questions. These are great questions. Things are weird, I know. Okay. All right, so let's talk about 2A. So unit 2 is our unit conversion unit. And so we are going to start with the sets of units that we are accustomed to, meaning we deal with the standard/American system. And then in 2B, we're going to get into talking about our metric system, which is so silly that we don't use because it's all just powers of 10 and we don't have these bizarre odd units of measure equivalencies. And then in 2C, we will look at converting between the two systems. Okay. So today we're going to focus, like I said, on the American system. This first box that you see at the top here is just relating the ideas of length, area, and volume and how we look at those units of measure. So if we think about length is a linear unit. They're just standard units. So we have inch, feet, and yards. You could also have miles under there. And and we think about miles, we shorten that to MI, not just M, because M on its own means meters. MI indicates miles. And so then when we get to area, and we're talking about units of measure for area, remember to find the area of, say, a rectangle, we would have length and width. So the area is equal to length times width. And so since we're multiplying two units of measure against each other, that creates a squared unit. So for inches, we would have inches squared, or we also write that as square inches. Obviously, if we were dealing with feet, it would say feet squared, or square feet, or square foot. Also, we use that term. Obviously, for yards, it's yards squared, or square yards. So then when we move from area into volume, volume is a three-dimensional space. And so we are taking the length times width of our base, and we're going to multiply it times a height. Now, this is only for talking about three-dimensional spaces with rectangular bases. It's also sometimes referred to as rectangular prisms. We're not going to get into a whole bunch of stuff in regards to like geometry and finding the volume of like spheres and cones and all sorts of ridiculous things. We're literally just going to deal with like cubes and like boxes, you know. So again, volume, because I'm multiplying 3 units of measure together, we get units cubed. So we would have inches cubed, also written as cubic inches, CUIN. You would have a space in between those. You could write it out as cubic, CUBIC, and then inches. Again, it's going to be cubic feet or cubic yards. Again, all of this, the only reason why we're writing this out is to remind ourselves, where are these units of measure coming from? Why are they cubic inches? And it's because we have 3 units of measure we are multiplying together. And so remember, multiplication, we represent that with, if we do repeated multiplication, that gets represented with exponents, okay? So in number 1, it says a room is 12 feet long by 10 feet wide. Always draw a picture. If you have a situation where you can draw a picture, always draw a picture. So what is the area of the room? Remember, area is length times width. So we're going to have 12 feet by 10 feet. 12 times 10 is going to be 120. Since I'm multiplying feet by feet, that's going to give us feet squared. So the area of the room is 120 square feet or feet squared. A box is going to be 6 inches wide, 4 inches deep, and 10 inches high. You can see my very terrible 3-dimensional drawing skills here. We got 6 inches, 4 inches, and 10 inches. Obviously, this is not to scale, but it's just a visual representation. Again, we're drawing a picture in order to give us space to put our units of measure. So we want to know the volume. So again, volume is equal to length times width times height. So I'm going to take my 6 inches times my 4 inches times my 10 inches. 6 times 4 is 24. 24 times 10 is going to give us 240. And since it's inch times inch times inch, we get inches cubed. All right, I want you to try number 3. There's 2 problems you're answering there for number 3. It says a warehouse is 40 yards long and 25 yards wide, and it's piled with cartons to a height of 3 yards. What is the area of the warehouse floor, and what is the total volume of cartons? And so I said, assume that there's no space between the cartons. So again, we would have this warehouse, right? And then it's 40 yards by 25 yards, right? And then we're gonna put cartons on it, and those are gonna be 3 yards high. And so if I were to break this up, like I said, you're reading my really terrible three-dimensional drawing skills here. What is the volume of those cartons? Again, assuming it's 3 yards high. So, and there's no space in between because they're all smooshed up against one another. So again, I want you to tell me what's the area of the warehouse floor, and then what's the volume. This is Sam, everyone, in case you were wondering. He's big whiny face. What are you doing? Oh, 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 come on. Okay, so our area is the floor. So we're gonna have 40 yards by 25 yards, which equals 1,000 square yards. And then with our volume, we're literally just taking our area and multiplying it by the height. So we're gonna take 1,000 yards squared times our 3 yards. Oops, there's no unit of measure on there. And we get 3,000 yards cubed, or cubic yards. Okay. All right. So the last one, again, I want you to do number 4 on your own. It says a flat bottom reflecting pool has a length of 30 yards and a width of 10 yards and a depth of 0.3 yards. Find the area of the surface of the pool and then the volume of water that it holds. Okay, so our area is going to be 30 yards by 10 yards, which gives us 300 yards squared. And now our depth is 0.3 yards, otherwise known as 3/10 of a yard. So we couldn't say that that was a foot, because a foot is 1/3 of a yard, right? So we need to make sure that when we're doing these, we have to have all of our units of measure match. So if I had told you that it was 30 yards by 10 yards and it was a depth of a foot, we would have had to convert that foot into yards before we could find this volume. We're not getting to that point until the next page. So we're just keeping things simple here. So when we take this for the volume, we're going to take 300 yards squared, multiplying it by 0.3 yards, and this gives us 90 cubic yards. Not that we would actually measure water that way, we would measure it in terms of gallons, but again, we're just talking about finding volume and what does that look like. So if we go to the next page, we're now getting into unit conversion. And so in your notebook, at the back of your notebook, if you look on the, what is it, on the table of contents, under the appendix, you'll see unit 2 conversion chart. And so if you want to flip to the back of your notebook, you will want to have that. And you want to pull it out. So I'm going to pull it up on my notebook or on my thing here, so we can all look at what I'm talking about. And this is something you're going to want to have handy to you as you're completing your homework and your notebook pages in this section. Now, don't worry. I don't want you to freak out and then be like, oh my God, I have to memorize all this. No, you don't. We have copies of them when you go to take your test. So you just need to know how to do unit conversion. You don't need to necessarily memorize any of them, okay? So let me pull this up. So if you look at this conversion sheet, this is what's in the back of your notebook. So I have it zoomed up right now. Oops, hold on one second. So the way that we look at this first section, this is on the front page of it. We've got the American conversions, okay? The bottom part is the metric conversions. And then if you go to the next page, and this is what we'll deal with once we get to C, this has to do with converting between American and metric. And right now this looks bizarre because I've got on the left-hand side, American to metric, and on the right-hand side, it says metric to American. And what that means is that you look at what are you starting with and what do you want to end with? Meaning if I say convert inches to centimeters, you would choose from the first column because I'm going from an American unit of measure to a metric unit of measure. Versus if I gave you kilograms and I wanted you to tell me how many pounds it was, that's starting with a metric unit and going to an American unit. So we would choose stuff from the second column. Again, we will get into this more when we get into 2C. I just want you to understand what the two sides of this document meant. And then at the bottom, we've got some additional units of time, and then we will get into temperature conversions later as well. So, but for today, we are going to be focusing on just that top box, the American conversions, okay? You'll notice where it says, I've got some units of length conversions listed, a unit of area. So we have acres. So 1 acre is equal to 43,560 square feet. I've got units of weight. So we've got pounds to ounces and tons to pounds. And then units of volume. This is liquid volume. I know we were just doing solid volume. Okay, and so we don't have any preset units of length conversions for solid volume on here. You will have to derive them. You'll see what I'm talking about later. Bailey, I see your comment about, and I will check to make sure they should have gotten mailed out like 2 weeks ago. So I will check to make sure that they got sent. I'm sorry that you haven't received your notebook. Has anybody else received or not received their notebooks yet? Who is waiting on me to send them one? Okay, so Hayden, you got yours. Anybody else? Okay. Bailey, will you send me an email again with your address, just so I can check the address that it maybe got sent to in case they messed up how they sent it to you? So again, if you can just send me an email so I've got that address and I can forward it to Grace to make sure that it got sent to the correct address, that would be great. Okay, so going back to our unit conversion. So we want to convert inches to feet, okay? So if we look at our conversion sheet, we know that there's a unit conversion that equates 1 foot with 12 inches. Now, I am going to do unit conversion using something called dimensional analysis. It's a fancy word, don't get scared. It just means that I'm using units in order to write out my conversion. Now, a lot of students tell me, Erin, why can't I just do this in my head? I know what it is. What's the big deal? But it's good to practice writing out these series of unit conversions, because we will get into chain conversions where we need to use a lot of them. And it helps to practice it with the small ones when we get to the big ones. So I want to convert 12 inches to feet. So I'm always going to start by taking the unit I want to convert and placing it over 1. So I want to convert 12 inches to feet, okay? Now I know that 1 foot equals 12 inches. That's called my unit conversion, or my unit, excuse me, my, oh my gosh, what is the term for it? I can't think of what they call it, but right now my brain's just not working. So what that is it's our unit ratio, because 1 foot literally equals 12 inches. Those are equivalents to each other. And so I'm going to set this up as a fraction. Now, the idea is, do I want to do 1 foot over 12 inches? Or do I want to do 12 inches over 1 foot? Because there's 2 ways I can write that unit ratio, okay? So when I'm looking at which way I want to write the unit ratio, I'm looking at what my starting units are. And I am trying to go from inches to feet. So whatever unit I'm trying to cancel out or convert from, that needs to be in the denominator of my second fraction. So if I have inches in my numerator up here, that means I need to have inches in my denominator in the second fraction. And so that means I'm going to put 1 foot in the numerator and 12 inches in the denominator. Again, I'm always looking at using, when I'm doing this dimensional analysis unit conversion, I want my measurement that I'm trying to cancel out to be diagonal, because when I multiply through, I'm going to get 120 feet over 12, because the inches will cancel with the inches. When it's in the numerator and in the denominator, they cancel each other out. I will do that final division. So 120 divided by 12 gives me 10 feet as my 10 feet, yes, my final answer. So again, when you take that unit conversion, that unit ratio of 1 foot to 12 inches, right? We need to decide how we want to write it as a fraction, depending on what unit needs to go in the numerator versus the denominator. And then we can do our conversion. So if we look at number 2, I want to convert feet to yards. So if we were to look at our conversion sheet, we know that 1 yard equals 3 feet. So I'm going to take my 24 feet and I'm going to put it over 1 because I'm always putting my first unit in the numerator. And then I need to decide where are the yards and the feet going to go in my second fraction. And then what is it equivalent to in the end? So I want you to try number 2 and send me your answer in a direct message. Okay, so because I'm trying to cancel feet, that means feet need to go down here. Since we have 3 feet, that 3 feet is going in the denominator. The 1 yard is going in the numerator. When we multiply straight across, our feet will cancel with each other. And I get 24 yards over 3, or 8 yards is our final answer there. So I don't want to waste too much time on these single conversions. I would like you to practice these ones on your own. You can check your answers against the solutions that are posted in Eagle Online. So if you go to Unit 2 and to go to 2A, under at the bottom, you'll see 2A solutions, and then you can check your solutions against those. So again, I'm going to have you do 3 through 7 on your own, and we're going to move along to what we refer to as chain conversions. Okay. So again, before I move forward, just want to make sure, are there any questions about numbers 3 through 7 before I move on to chain conversions? Okay. So the reason they call them chain conversions is because it's going to require more than one conversion factor. So number 1 says convert 2 days to seconds. So if we think about time and our units that we know, if we want to go from days to seconds, that means we're going to go from days to hours, from hours to minutes, and from minutes to seconds. Right? That's our conversion for how we want to set this up. Okay. Which means I've got to use multiple conversion factors, right? So we know that to get from days to hours, we've got 1 day equals 24 hours. To go from hours to minutes, we know that 1 hour equals 60 minutes. And writing this intentionally to try to show how these pieces are going to overlap. And then finally, to go from minutes to seconds, we know that 1 minute equals 60 seconds. Okay. So you can kind of see how those units and measure are going to cancel each other out because of the fact that they overlap. So setting up this chain conversion, I start with my first unit, which is the 2 days. And I always going to place it over 1. From there, we know we want to get from days to hours. So we're going to use our first unit conversion here that says 1 day is equal to 24 hours. Okay, so that allows us to cancel the day portion out. So now we have hours. So now we need to go from hours to minutes. So again, we're going to use our next one here that says 1 hour is equal to 60 minutes. And then our last one because we've now canceled our hours out. Our last one will be the 1 minute is equal to 60 seconds. It's really great when we're able to get ones all the way across the bottom, because again, we just have to multiply along the top. So days were diagonal, that's what allowed us to cancel days. Hours were diagonal, again, that's how we were able to cancel the hours, and then minutes. So now we just need to work through, and we're gonna do 2 times 24 times 60 times 60. And this gives us 172,800 seconds. And so that's what I mean by a chain conversion. We're doing a chain of them. This all follows under that heading, like I said, of dimensional analysis, and it allows us to do multiple conversions at once. So number 2 says convert 2.5 miles to inches. So if we look at our conversion sheet, we're trying to go from miles to inches. Now, we don't, because in your mind you may go, okay, well, we have miles, and then we have yards, and then we have feet, and then we have inches. We don't necessarily have to use all of them if we have conversion factors that span those. And we do have one. So 1 mile is equal to 5,280 feet. So because we have a conversion factor that goes from mile to feet, we don't have to worry about bringing yards in. Okay, so we don't need to worry about adding that extra piece. So because we're trying to go from miles to inches, we're going to go miles to feet and then feet to inches. So we're going to use these 2 conversion factors right here. So if I go back to my page, I'm going to write down that I know that I'm trying to go from miles to inches, which means I'm going to go from miles to feet and from feet to inches. We know that 1 mile equals 5,280 feet. And we know that 1 foot is equal to 12 inches. So I want you to try number 2 on your own. Send me your answer in a direct message. So we're going to have 2.5 miles. Oops, that looks like minutes. That's not what we're doing. We're doing miles. And again, we want to go from miles to feet. So I'm going to use this first conversion factor here that says 5,280 feet is equal to 1 mile. And then I'm going to use getting from miles to, or excuse me, from feet to inches. Because again, this first conversion allows me to cancel out those miles. So then our next one is going to be 12 inches to 1 foot. So now I'm going to get those feet canceled. And if I multiply across 2.5 times 5,280 times 12 gives me a total of 158,400 inches. Coincidentally, the elevation of both Denver and Butte is 5,280 feet, which is why they are referred to as mile high cities. In case you wanted to know why they say that, there's an actual reason. It's not just a random statement. So number 4, we're going to convert 17,200 miles per hour into miles per second. So this is a unit conversion where we have 2 different units in it. So we have 17,200 miles. And then, so miles per hour just means miles over 1 hour. Remember we talked about last week, the word per means division. So it's miles over hours. And so we want to get to miles per second. So what that tells us is that we're not worried about converting the miles portion of this unit rate. We're worried about converting the time portion, the hours. Okay. So we're going to leave miles alone. We're just going to leave it there. So we're going to focus on converting those hours, which are in the denominator. So remember, we want to get from hours to seconds. So we need to go from hours to minutes and then minutes to seconds. So we're going to use the first conversion that says 1 hour is going to be 60 minutes. And then the second one that says 1 minute is going to be 60 seconds. So you'll notice when I'm looking at canceling my units of measure, we predominantly have been going from the numerator to the denominator, right? We've been canceling that way. It's possible to go the opposite way as well. So this hour will cancel with that hour. This minute will cancel with this minute. And what I'm left with, you'll notice, is miles in my numerator and seconds in my denominator. So if we multiply straight across the top, I'm going to get 17,200 times 1 times 1. So just 17,200 miles will be my numerator. In the denominator, I have 60 times 60 seconds. So 3,600 seconds. Now, the question or statement, however you want to refer to this, says miles per second. That indicates that we want a single second in our denominator. So all we need to do is divide. So we're going to take 17,200 and we're going to divide it by 3,600. Now we do get a decimal number here. We get 4.7 repeating. And so we want to round this off, and we're going to say that is approximately equal to 4.78 miles per second. Now in your homework, it will tell you how many decimal places to round to. It'll say to the round to the nearest 10th or 100th. So you want to pay attention to that, to those instructions. And they're usually written in blue in like parentheses at the end of like your, at the end of the question or something along those lines. So again, it's possible to have unit conversion where we don't convert both units that are in the problem, right? So we didn't worry about the miles. We wanted to keep those. We were just converting the time portion of it. So that one's a little weird with the fact that, you know, we're leaving some units and not others. So before I go on to number 5, are there any questions about number 4? Okay. So number 5 says, suppose you bought 10 6-packs of soda, each 6-pack containing 6 12-ounce cans. How many gallons of soda did you buy? Why would we even care about this? Well, we could be looking at, you know, comparing the price, right? Like, is it better to buy gallons or 2 liters versus 6-packs or whatever? It doesn't matter. We're just doing unit conversion here, and I'm coming up with ways that we can practice this. So I'm saying you bought 10 of these 6-packs, and each 6-pack contains 6 12-ounce sodas. Okay. So I don't want you to get caught up in the number of times the word 6 is used. I know that's a little confusing. So we have 10 of them, and in 10 of those packs, there's 6 cans, and each of those cans has 12 ounces. So the thing I want us to find first is the total number of ounces that we bought. I want you to tell me how many ounces you think we bought of soda.
72.
Huh?
72 ounces? Oh, 10. Oh, never mind.
Mm.
I saw the 10.
Yeah, there's a lot of numbers there, right? So we've got 10 of those packs with 6 cans each, and each of those cans is 12 ounces, right? So if we multiply all the way across, that's going to give us 720 ounces of soda, right? So now I want to know how many gallons is that, right? So if we look at our unit conversion, I want to go from ounces to gallons. And there's a lot of steps we have to take, right? Looks like we got to go from ounces to cups, cups to pints, pints to quarts, and then quarts to gallons. Okay. Now you may find out in the internet somewhere shorter conversions and things like that. When it comes time for you to take your quiz and take your exam, I'm going to look for every single one of these steps. So I don't want you to get into the habit of like going and finding some random conversion, because especially when you come to take your exam, we won't let you bring in your own unit conversion sheet. You have to use the one that we have there. So I don't want you to get too accustomed to using shortened conversions or conversion websites or any of those things to do these steps for you. There's a reason why we have these conversions laid out. And so, you know, you want to get into the habit of using those. So what I'm trying to say is that to do this problem, you want to use all 4 of these conversion factors. Okay. So again, convert those 720 ounces to gallons and send me your answer in a direct message. Okay, so if we convert this, we're gonna take the 720 ounces and place it over 1. Using our first conversion, we're gonna put 1 cup over 8 ounces because again, we're trying to cancel those ounces out. This leaves us with cups. From here, we are going to take our next conversion factor that gets us from cups to pints. So we're gonna do 1 pint to 2 cups. Again, now we're at pints. We're gonna go from pints to quarts. So 1 quart is equal to 2 pints. I will tell you, the pints to cups conversion, and the pints to quarts, I never remember those. I remember that there's 4 quarts to a gallon because of the fact that quart means quarter. And so there's 4 quarters to $1, there's 4 quarters of a whole, there's 4 quarts to a gallon. I remember that, but again, the ones in between, I remember ounces to cups, but the 2 pints to 1, or the 2 cups to 1 pint and 2 pints to 1 quart, I can never remember those. So don't feel bad if you struggle to remember all of these. A lot of them you're not going to use in your daily life, right? The ones that you do use, you end up memorizing. If you're going from here into Math 140, there will be more unit conversions specifically for medical units. And again, there will be medical conversion factors you will have to memorize for your daily life in your job, not your daily, everyday life. But nonetheless, if we multiply through, we get 720 over, what is it? 8 times 2 is 16, times 2 is 32, times 4 is 128 maybe? Yes. And pints cancel, quarts cancel, this is gallons. So doing the division, we get 720 divided by 128. And this is 5.625 gallons. And yes, you could have rounded to 5.6 gallons. I didn't round it only because this terminates. So it didn't matter to me right now, but yeah. So that is a big chain conversion. Obviously, there's many steps there. And yes, I know that you could come up with conversions that are shorter, where you could just say, well, 1 gallon is equal to 128 cups, right? Or 128 ounces, excuse me. But that's not what we're going to have available to us when we take the exam. And so it's good to practice all of our steps in between. So on the next page, keep going because I put those in between. Number 6 is a really interesting one. We're not going to go through it. I do encourage you to go through it on your own because it sort of puts into perspective the insane salaries of these players. So this is true information. In the 2012-2013 season, Kobe Bryant earned $27.8 million to play 80 games, and each was 48 minutes. So I really encourage you to go through A, B, and C on your own. You can check them against the solution set. It gives you kind of an insane idea. And again, this is over 10 years ago. Like their salaries are even more nuts now. But I'm going to have us jump down to area conversions because students in general really struggle with these. So the whole reason I had us talk at the very beginning of the unit about looking at our units of measure for length, area, and volume is because we do end up doing conversions between square feet and square inches, square yards and square feet, cubics, all of those things. So number 1 says convert from 1 square foot to square inches. So we know that 1 foot is equal to 12 inches, okay? So one of the places that students make mistakes with these area conversions or volume conversions is they forget to think about all the dimensions that make up area and volume. So if I'm talking about 1 square foot, 1 square foot, that was made by taking 1 foot and multiplying it by 1 foot. right? That's how I made the square feet. So because I know that 1 foot is equal to 12 inches, I can substitute 12 inches in for each of those feet. And so multiplying through, I know that 1 square foot is equal to 144 inches squared. Now, if you want to write on your unit conversion sheet this conversion to use later, that's totally fine. Just know that when you take the exam, you won't have that conversion available to you, okay? But it is good to have written down for you to know, okay? So I want you to think about what I did in number 1 and try number 3. And the reason why I'm having jump to number 3 is because we're now going from cubic feet to cubic inches. And so again, we're still dealing with that idea that 1 foot is equal to 12 inches. And so we're going to do 1 cubic foot to blank cubic inches. So I want you to try number 3. Send me your answer and then direct message, and then we'll talk about 2 and 4. Okay, so because we're doing cubic feet, we know that a cubic foot is found by taking 1 foot times 1 foot times 1 foot, right? That's how the cubic part comes about. So if I substitute 12 inches for all of those, then I'm doing 12 times 12, which is 144, times 12 again, which gives us 1,728 inches cubed. So our final conversion would be 1 cubic foot, or 1 foot cubed, is equal to 1,728 inches cubed. So again, this is where writing out the pieces allows us to make sure that we are using all of those factors we need so that we don't mismultiply, right? So I want you to try number 2, and then we'll go forward from there. Okay, so we're going from yards, excuse me, square yards to square feet. So we have to think about what is a yard squared? Well, 1 yard squared is equal to 1 yard by 1 yard. And we know that 1 yard is equal to 3 feet. So we can substitute 3 feet in for those yards and we get 9 square feet. Okay. All right, so you can do 4 on your own. It's just like number 3. We're just multiplying by another factor of 3. So let's go to the next page. It says Billy wants to carpet a room that measures 12 feet by 10 feet or 10 feet by 12 feet. But the carpet he wants to buy is sold in square yards. How many square yards of carpet does Billy need? So there's 2 ways we can do this. We could think about converting our feet measurements to yards first and then finding the area. Or we can find our area in square feet and convert our square feet to square yards afterwards. Again, both ways are fine. One thing I will tell you is that thinking about converting those individual measurements, 10 feet is not a nice number of yards, right? Because 10 is not evenly divisible by 3. So if we were to take the 10 feet and divide it by 3, we end up with 3 1/3 yards. And the reason why I am writing it as 1/3 is because 1/3 is not a terminating decimal. So this is a situation where, and you don't want to round off, right? If you were to round off, Billy could end up not purchasing enough carpet. So you're better off in this situation finding your area in square feet and then converting your answer from square feet to square yards. Okay, so I want you to try number 5. Send me your answer in a direct message to the nearest 10th. Okay, so like I said, it's not helpful to convert to begin with. So if we're looking at Billy's room, it's 10 feet by 12 feet. So the area is 10 feet. Oh goodness. 10, oh, for the love of God. 10 feet by 12 feet, which gives us 120 feet squared. Okay. So this is why I did the previous unit conversions. What did we learn just before? If we're converting from feet squared to yards squared, what is our unit conversion? Well, to remind ourselves, 1 yard is equal to 3 feet. 1 yard squared is equal to 1 yard by 1 yard. So if we substitute in, we're going to have 3 feet by 3 feet, which means 1 yard squared is equal to 9 feet squared. We are dividing by 9, not 3. So setting this up, we're going to take 120 feet squared. We're going to multiply it by 1 yard squared over 9 feet squared. And when we do that multiplication, we're really ending up doing division, right? We have to take 120 dividing by 9. Our units of measure will cancel here. And this ends up with 13 1/3 yards squared. So I said round to the nearest 10th because I know you guys like decimals. So we would say 13.3. Now, if Billy was literally going to the carpet store to buy this carpet, would he buy 1/3 of a square yard? No, he would just round up the whole square yard. And most likely that's what your homework's going to ask. It's going to say round to the nearest whole square yard. I know by our rules of rounding, you would say, well, Aaron, that decimal is less than 5. Why wouldn't we round down? Well, we round down, Billy's gonna have a corner of his room doesn't have any carpet in it because we would be shorting ourselves. And so we would say that this is actually approximately equal to 14 yards squared if we were going to round to the nearest whole square yard. So again, this is a situation where we want to pay attention to what is the context of the problem for when they're asking you to round. Okay. All right, so that is our time. I want you to finish trying the rest of those ones on your own. I know that there's a lot of practice problems in these sections. And so that makes our time run a little bit long. So again, do more of them on your own. Check your work against the solutions. Tomorrow, I'll go over the quiz. So don't forget that's due tonight. Make sure you get that done. And I'll also answer questions about the gradebook project and stuff like that. So any questions for me before I let you go?
No, ma'am.
Okay.
Thank you.
You're welcome. All right. Have a good day, everyone. I will see most people tomorrow. Bye.